we're going to go through how we multiply decimals. So we're going to go through the estimating of the product. We're going to analyze patterns to help us understand why, what's happening. We're going to do decimals by whole numbers. Then we're going to figure out the standard algorithm, multiplying two decimals. And if we get to it, we'll solve a couple of riddles involving area and volumes. Our first step, we want you to round each decimal to the nearest 10 and then to the nearest 10. So you've got two of them to do for each of these problems. You're doing one estimation to the nearest 10 and one to the nearest 10. So you're doing that for all six of those numbers. I'll give you guys about 2 minutes. There you go. I'm going to start in order. So the tens, and I'm looking at that place. So this one is going to drive it. A 9 means the 1 becomes a 2. All right, if it's 10, that's a 20. Nearest 10, that's the place I'm rounding to. Means I look at the 4 means it stays the same. So it'll be 19 and 5/10. I'm looking to round to the nearest 10. So I look at that 1. 1 means it goes to 10. This is the nearest 10. 10, then 9, I look at the 6. 6 means it goes up to 10. Thinking that goes up to 12. It is 11. 10, looking at this place. So the 4 means it. 10, I'm looking at the 3, meaning on 5. It's going to go up by 1. 10 is I'm going at the 4. I look at the 5, means that becomes 250. Tenths, I'm looking here, means I look at the 3. The 9 in this case is completely irrelevant. 245 and 3/10. 10 means I look at that 0, doesn't do anything, that's going to be 10. 10, I look at the 8, it goes up 1. 10 and 9/10. 10, looking at the 10th place, that 8 means it goes up 1. 1,260. 10, means I look at that 4, it stands the same. Are we good on those? Yeah. Good. I'm rounding to the nearest 10. Right? So the 1 means that it goes. Not worried about that. If I'm rounding to the nearest 10. 1. So my 10th place is 1. 10. So 1 means I don't change it. It's 10. I think should be really easy. Guys, other questions? Other questions? Okay, let's go to the next page. I kind of did an experiment with last class. It didn't go so well, so it's different than you guys. Everybody does see 2 different colors. Any color pencils or markers? On this one, we've been using these area models quite a bit. We did it with fractions, we did it with areas. So we're going to show the product of 2 fractions. Then we can do the product of 2 decimals. So the first one, they want us to write the multiplication problem represented by the area model. So we're going to write out this entire thing. So if I look at this, here's one of the keys. I know this is out of 100, yes? 10 by 10, everybody okay with that? Okay? As I go across for my first number, how far across did I go?
1.
1, 2, 3, 4, 5, 6, 7. So how do I write that? 7/10. Then now, so I went this way. Now I'm looking this way. How far up did I go?
7.
1, 2, 3, 4, 5. Got it right there. You put a 0 part of the need to. Now, if I count, how many of the dot boxes have 2 colors?
3.
More than 3.
4.
Count how many are in there?
3.5.
35. 35. But it's 35 out of how many? 100. So 3,500. Does that make sense?
Yes.
And hold on. As being honest, I really appreciate, and I assure you, she's not the only one. So Savannah, which part of it don't you understand? You don't understand that that is 7/10 across? Did I cover all those? Savannah? Well, you said you understand all of it. You don't understand. I colored in 7/10 of them. Okay? You understand that part, yes? So then you don't understand I colored in 5/10 of them coming out. Oh, you do understand that. Okay? So that was 7/10 across by 5/10 up, yes. So now I look at what did double shaded. What got both colors? How many was it? 35. You can literally count it. There's 35 boxes in there. But this is 35 out of how many in the total shade? 100. So 3,500. Does that make sense? Are you sure? All 3 parts of it. Okay. Now I'm going to test you. So now I'm going to do 100 spin to model the expression, 2/10 times 8/10, and determine the product. So I've got 2 parts. I need to model the expression, and I need to figure out what the answer is. So the first thing I'm going to do in modeling is I'm going to do my first number. So my first number is 2/10. So how would I color that in? Top to bottom, how far? 2. So I color in top to bottom for 2 of them. Does everybody agree that that is 2/10? I know you guys aren't getting colors pretty as I did. Okay. I'm pretty much in the line. Hey guys. Morning. So our 2/10, I'm going to take that 10. So if I'm going to do 8/10, that's second. So there's my 2/10. Now I'm going to do 8/10. Actually, go yellow this time. I'm going to do 8/10 the other direction. Meaning, if I start at the bottom, and we come up 8/10, we color in all of these. Oh, does everybody see the 2/10 and the 8/10? Okay, now to find our answer. What we need to now do is count our double colors. So I did 2/10 times 8/10. How many boxes have 2 colors in them?
12. 16.
Try to count again. Should have found 16, but now 16 out of 100. And now I'm looking at the whole box. 1,600. Does everybody understand the process we just went through?
Yes.
Okay. So you now have seen the area models on these. Benny says the product of any two decimals that are less than 1 will always be less than 1. Angel says the product can be greater than 1. Who is correct? There's our question. But I circled a couple of, or boxed a couple of key phrases for you. Benny says it will always be less than 1. Angel says it can be greater than 1. So tell me who's correct. Use the area model to help you explain your reasoning. I will let you guys talk about this one as a table. 2 minutes. 2 minutes. We're gonna see. Okay. Of the reason you thought Angel is correct. The fact. I appreciate the fact that you're looking at the testing. Normally, if it says always, that is going to be false. Why? Because one time I find people that is against that means it's incorrect. It is really hard to get an always statement that is true. Normally, if I have a can be, that is a really good indication that's the correct answer. Except in this situation. Because in this situation, it will always be true. Is there any way I could have a number that doesn't reach the top here? And Isaiah, you said add. And that's the key. Are we adding?
No.
No, we are multiplying. So, if we were adding, Isaiah would be correct. But because we are multiplying, there is no way I can get a number less than this and a number less than this and find something that's going to be bigger than it. Can't happen. So in this case, Benny is correct. Okay, we're on 137. We're going to investigate strategies for multiplying decimals. Kenji needs to calculate the area of the floor in the hallway of his house so he can buy new carpeting. It's 32 and 7,500 feet long, 7,500 feet wide. He says, I can use estimation to help place the decimal point correctly in the product. Guys, here's a key. And this is actually our algorithm for this. So let's highlight this. Multiply decimals as you would whole numbers. And then place the decimal point in the product. This is what makes multiplying decimals easy. Remember your rule for adding and subtracting is I must line up my decimal. That is not the rule for multiplying. In multiplying, my whole key is the decimal product placement. You got to put the decimal in the right place in the product. So Kenji's going to use estimation. Let's see if this works. He says 32 and 7,500 is close to 30. That?
Yeah.
He says 7.5 is close to 7. Somebody good with that? I would say 8, but is 7 actually reasonable? Yeah. So if I do 30 times 7, that's 210, right? Yeah. Pretty good so far. Okay. He then uses a calculator, and he finds out if I multiply 3,275 by 75, I get 245,625. What he knows his answer should be 210. So now all he has to do is put his decimal place. If you put the decimal place after the 2, is 2 close to 10? No, not even. Is 24 close to 10, 210? No, not even in the area. It's 245 close to 210. That's pretty close, right?
Baby.
If I kept going, it's 2,456 close to 210. Well, so knowing that I have the numbers, guys, knowing that I have the numbers correct, my estimate can help me place the decimal because it's going to say, yeah, the one that makes sense is 245. So it's 245 is 245,000 square feet. Does that make sense for everybody? Okay? So we're going to use the estimation strategy to insert a decimal point in each multiplication sentence to make the sentence true. In other words, what they have done is they multiplied 526 times 83, and they gave you what the calculator would spit out. In this case, 43,658. Your goal is now we're going to use that estimation strategy. 52 and 6/10 is close to what? 53 is close to what? Close to 50. 8/10 is close to 1. 50 times 1 gives me 50. So where would I put my decimal place in that entire string of numbers? It's going to give me an answer that's 50. Behind the 3, because then it's 43. 43 is close to 50, yes? So the answer is 43 and 658,000. Somebody understand what we are doing? So you've got 2 more to do. Show me your estimation. Then put the decimal place where you think it goes in the answer. Okay, I'm going to go through this rest of it quickly because I want to make sure we get through the rest of the lesson. 7, 9, 10 should have been close to 8. 6, 10 close to 1. 8, so the decimal comes after the 4. 94 hundredths is close to 1. 24 9/10 is close to 25. 1 times 25 is 25, so it goes between the 3 and the 4. Guys, is this making sense for you? Yes. Yeah. That would be 234. 234 plus 25.
Whoa.
Are you talking B or C? B is behind the 4. Between the 4 and the 7. Four is close to 8. Okay. So we'll check the recording to be sure. But I'm pretty sure I did it right. Okay, go to the next page. On this one, using a pattern to be helpful in how to calculate the product in a decimal multiplication problem. So your job is complete the table. I'm going to give you a big hint. Start with where it's 1. All of you should be able to multiply a number by 1. As you go from there, you start to see patterns. So you're going to fill in all 18 blank spaces. 18, 3 columns, 6 in each one. And then you're going to describe any patterns you see. Guys, you know there's 18. Which one you're going to see the pattern quickly or you won't? I'm only going to give you guys 4 minutes to finish off this table. Okay, guys, if I start at the 1, 1 times 32 is 32. If I multiply it by 10, then it becomes
220.
20. To 100, then it becomes. That makes sense for everybody. So all we're doing is adding a 0, correct? Well, what's going to happen now if I multiply by like 10? Now it becomes 3.2. Then it becomes
200. 32,000.
Makes sense? Okay. Now, if I start at the 3 and 2/10, now it's just 3 and 2/10. As I multiply by 10, and here's one of these guys. Do I just add a 0 at the end? No, I move my decimal one, right? Now it becomes 32. Now I do times 100, so it's going to become 320. Same thing happens as I go down. Now it becomes
3,200.
3,200,
32,000.
32,000,
32,000.
32,10,000. Everybody good so far?
Yeah.
Okay. Now if I start with one that's in the hundred, if I multiply by 10, again, I'm just moving my decimal over 1. Now it becomes 2 tenths. Then I move it over twice, it becomes 32. As I go the other way, and I'm moving it one further over, but in order to keep my point value, and I need to insert a 0 in there. 32,000, 32,000,
32,10,000.
10,000,
3,200,000.
200,000. How does it
By the 32, and then it goes to the next one.
Right, only David she's talking about.
So for the 32 times 1, and on the table, it keeps increasing because you're adding the
How does it increase? How does it increase?
vertical direction.
Okay, but how did it increase?
By times.
What do you mean by 10 measure?
Like a house.
Okay, a whole lot of times, never what happens when I multiply by power. There's always another 0?
If you're so it's only when you're
This table needs to stop talking. Table, that's you guys.
sometimes
How do I know that when I add 0? I'll give you a hint. There's your key. I just pointed to that decimal place right there. Am I really adding a 0? No, I'm not. What am I doing? I'm moving the decimal point. So, as I multiply by 10, I move the decimal right. As I multiply by tenths, I move the decimal left. Okay? They are both still powers of 10, right? So your whole key is how many powers of 10 tells me how far I'm moving it. 1 power of 10 means I moved it once. 2 powers of 10 means I moved it twice. 3 powers of 10 means I moved it 3 times. Blank spots always get a 0. Same thing if it gets bigger. I'm still just moving it right once, but blank places get a 0. Empty buckets get zeros to hold my place time. So really, guys, all I'm doing is moving my decimal to the left or to the right. Does that make sense for you? Did I hear someone say no? Everybody thumbs up. Everybody thumbs up if you're good on that. That makes sense. And all I'm doing is moving my decimal as you power to 10. Thumbs up? Guys, I got a lot of people still writing. I need thumbs. Fingers work, okay? Okay. Looks like most of you are good on that. So, now that you have that concept down, now we're going to put this into place. So I know from my fact families, 26 times 31 is 806. So I need to use what I've just learned about my decimals to help me place my decimals. I will give you a hint. The answer to every one of these problems is 806. Every one of them. Because when I multiply those two numbers, I'm going to get 806. That's what's going to change for every one of those. Where my decimal is. So basically what I want you to do is go through and figure out where my decimal place is for all 8 of those answers. Okay? And then you got about 3 minutes to figure out where the decimal goes. Zeros are very important. Zeros will play time. Put 806 in the right spot. Good luck. Guys. On the back side on this one, I have 1 decimal there and 0 here. How many should be in my answer? 1. I have 1 decimal here, 1 decimal here. I'm sure. 2. 2 here, 1 here. 3. 1 here, 2 here. 3. 2 here, none there. 2. 1 here, 3 there. 4. That's where those zeros come in. It has to go before the 8. 3 here, 2 here, 5. So I need 2 zeros. 2 here, 2 here, 4. You're seeing the pattern. Anybody not seeing the pattern? Maybe what part are you missing?
Like the zero, 26,000.
Okay, so the key is, I've got 1 decimal place here, 3 here, right? So I need to have 4 decimal places in my answer. All right? But if I have 806, I can't put it at the end because that changes the value.
That's greater than.
That's greater than. So I have to put it to the left to maintain my place value.
Oh.
Okay? Same thing on this one. In order to get the 5, I can't put it at the end because that changes my value. I need to make sure I'm moving it to the left, meaning I've moved the 2 more to the left, putting the 0 that way. Without changing the number. Good? Okay. So, how can I tell without multiplying which expressions will have the same product? The same with the amount of it, the ones with the same amount of decimals. Well, it really just comes down to how many decimals are in the numbers. That drives everything when you're multiplying decimals. Guys, this right here is what makes multiplying decimals the easiest decimal operation. Because if I add or subtract, I've got to make sure everything's lined up. I've got to have all my taking zero. There's a lot of organization that happens for adding and subtracting. And multiplying, I literally just multiply the numbers, and then I'm going to put that number of decimal places into my answer. So, Selena makes a statement. Does everybody agree? If I do 4 times 10, what does that equal? 40. So I just put a 0 at the end, right? What if I did 21 times 10? 210. What do I do? Put a 0 at the end. Everybody okay with that? Okay. So Selena says, I write a 0 at the end of a number multiplied by 10. So everybody's okay with that? Who said no? So everybody okay with that? So, and then I do 2 zeros to multiply by 100. Everybody okay with that? So she gives us 2 examples. 3 and 2 tenths times 10 is 3 and 20 hundredths. 2 tenths times 100 is 3 and 200 times. So, what'd she do wrong? After?
He did add, did change the word the decimal.
Already said. So I'll repeat it, and I'll show everybody here since it's the video. She just added a 0. She didn't move the decimal place. Because really, am I adding a 0 when I multiply by 10, or am I moving the decimal place? I'm moving the decimal place. So just adding the 0 at the end of it without moving the decimal doesn't work. So it's not really adding a 0 or 2. If I'm doing 100, it's moving the decimal place. Why? Because we use a base 10 system for our numbers. Because we use a base 10 system, what that means is I multiply or divide by 10, or multiply by powers of 10, including decimals, all I'm doing is moving by decimal point. The numbers will all stay the same. Is everybody okay with that? Okay? So, as we do this, 32 times 10 is 220, yes? 32 times 10 is 32, yes? 32 times 100 is 3200, yes? 32 times 100 is 320, yes? So how are those similar? What did we do the same? And then we move the decimal point. In all of them, we move the decimal point by how many zeros? Multiply by. In other words, when I multiply by 1 0, I move my decimal place once. 32. When I multiply by 2 zeros, I move my decimal place twice. 3200. Make sense? Okay. Now we're going to go to Camilla. Camilla says I multiplied these two numbers on my calculator, and I got 15 and 403,000. It should be 4 decimal places, correct? So she's saying it should actually be 1 and 5,403,000. Why not? Are you saying her calculator is right? Even though it only has 3 decimal places? Okay? Awesome. How many of you saw that? Say it again.
Calculator is right, but the last place value is a 0, so we don't need to have it.
The last place is a 0. Does that actually add to the value of the number? Do I need that 0?
No.
No. So when the calculator showed me a 0 I don't need. No. Okay? So calculator is correct. But the trailing 0 is not needed. Come here. So the calculator drops it. But if I didn't need that 0, the calculator doesn't display it, even though it's technically there. And if you think about it, when I multiply, that 2 times 5 is going to give me a 10, my first value, right? Then all the trailings will have zeros as well. Camilla, what did you do wrong? She just focused on the back. There's 2 decimal places here. 2 decimal places here, right? But she said I should have had 4 decimal places. So in order to put the 4 decimal places, she moved it over 1 in each spot. But had I done an estimate, 3 and 65 hundredths is what? About 4. 4 and 22 hundredths is about 4. 4 times 4 gives me 16. So if she had said, I estimated and found 16, which would make more sense, 15 or 1? 15. She would have known that the calculator had that correctly, wouldn't she? Is it hard to do that estimate? Okay. Guys, all we're trying to do is help you understand the importance of estimates. Number 1, they're easy to do. Number 2, it gives you reasonableness of your answer. That is the advantage of doing estimates. Okay, let's go to the next page. So, we are going to add the algorithm down here. So go to the bottom of the page. They want to put a dog here on this page to help you go back and struggle with multiplying decimals. But it's actually really simple. First step, count the number of decimal places. Step 2, multiply by there are no decimals. In other words, ignore the decimals. And number 3, put the number of decimals in your answer. So I'm going to leave that up there for you to look at as you're doing these. You have 4 problems on this page. You've only got about 10 minutes left. I still need to go with the homework. So I'm going to give you guys about 5 minutes. See how many of these 4 problems you get done. And then we'll go over those answers really quickly before I go over the homework for you guys. So try to do as many of these 4 problems as you can. 2. I know, time flies, right? Guys, our first one. It holds 16 9/10 fluid ounces, drinks 8 bottles. So how many fluid ounces do they drink each day? Well, I'm doing it 16 9/10 times 8. Here's how I do this, guys. When I'm looking, I count how many decimals do I have? 1. I just write it right here. Now I forget about it. So now I'm going to 169 times 8. It'll be 72. 48 and 7 is 5. 8 and 5 is 13. Put 1 decimal in my answer. So, going to drinks. 135 and 2/10 fluid ounces. That's how I do it. Okay? I'm going to do one more just so you guys can see another example of how I do the multiplying. We're buying 2.5 pounds sliced turkey. It sells for $6.72 a pound. How much will she pay? Well, I'm doing $6.72 times 2 and 5/10. I just count. How many decimal places do I have? 3. I got 2 in the top, another 1 in the bottom. Write it there and I forget about it. Now I'm multiplying 672 times 25. So 10, 35, 36, 33. Put my 0 placeholder. Gives me a 4, 14, 12, 13. Add them up. 0, 10, 8, 6, 1. I need 3 decimal places. So I go from the back. 1, 2, 3. So she paid $16.80 for the turkey. Is this making sense for everybody? I hope. Right now we need to go to your homework. So go to page 143. Go ahead and tear this out. We're not talking because we are recording. on your estimation. Guys, we use this estimation. How can I use it to put my decimal point correctly? That's your journal entry. Now, we're actually going to put that into practice. Insert the decimal places into each multiplication sentence to make it true. So all I'm doing is, this is the answer for 257 times 34. I just need you to put the decimal in the right place. That goes for all four of those. Here's where people lost a lot of points last year. I need to estimate each product first, and then calculate each product second. So how many answers should I have for all four of those problems? Two. I need an estimation and an actual calculation. Make sure you are showing your work. Going to the next page. Determine the volume of each figure. Volume, remember, is length times width times height. On this one, they've thrown a lot of curveballs. So, I've got a large outside one. I'm going to multiply length, width, and height. I have an inside one. It is a cube. 2 by 2 tenths. And my length is 1.2. I'm going to take number 1. I'm going to subtract the volume of number 2 to find the volume of the whole figure. For part B, I'm actually going to make this into a complex figure. I'm going to figure out the volume for this and the volume for this. Yes, they did. I mean, this is 5 tenths, so, and the whole thing is 9 tenths. So this is 4 tenths. I'll even give you guys an extra bonus hint when you're on the recording. Remember, it's still length times width times height. So this one, now I'm going to take number 1, and I'm going to add number 2 to get my total volume. Accurate.
So what's the length of the line?
9 tenths.